Good day, students and viewers. You are welcome to the studios of Mathsx. Today, we will be learning about number-based system. Number-based system. But before we start our presentation for today, we want to thank all our subscribers for the week. I want to say thank you for giving us some value. And we want to say again, God bless you. Thank you so much for doing what you've done for us. Being done with that, we are on number-based systems. First of all, every culture, every civilization has their own unique way of counting. Yes, in the part of Nigeria where we come from, we have our own unique ways of counting. Some tribes count in twos, some in fours, some in 12s. Yes, for instance, the Indians count in tens, and that's what we call the base 10 counting system. It actually came from India to Europe and then across the world. It is the most widely used method of counting. For me, my dear students and viewers, number-based system refers to the number of independent digits or notations used in any counting system. By this, I mean, if I have an expression like this, x with a subscript y, this x here refers to the number and the y here refers to the base. So what I have here, this is our base, that's what the y is, and then of course the x here talks about a number. So a particular number on a particular base, this subscript here is the base. So to rewrite this, let's do this. Maybe I have 5, 2, 7 on a base 8. So the x here is your 527, and then the y, which is your base, is the 8. So this number 527 is in base 8. Notice the way I called it. I didn't call it 527 on base 8. I called it 527 base 8. Mathematically, it is more expedient to write this number this way: 527 with a subscript. Most times students do fall prey to maybe inconsistent writing or maybe bad handwriting, like we say. The 8, most students do end up making the 8 a little too big so that it doesn't end up looking like a subscript or a base anymore. It looks like part of the number. I've had cases where students have done this: 527, and then they did an 8 here, as in this is supposed to be the base 8, but if you look at it, it looks as though it's part of the number. So this is a better way of expressing it, using words instead of figures before it gets mixed up in the number, because the intention actually was to display a base. And did you also observe something funny here, as in something strong here, not funny, something strong here, that the highest number in base 8 is 7. So when you talk about base 8, it has a couple of independent digits based on that definition I gave you, and the biggest of the independent digits in base 8 is a 7. To further elaborate on what I've just said, let's start with a base 2, my dear students and viewers. A base 2. Base 2 would have a couple of notations, as in numbers. That would be a 0 and, a 0 and a 1. Talking about a base 3, we'll be talking about a 0, a 1, and lastly a 2. Maybe even a base 4. We'll talk about notations like 0, 1, 2, and 3. Maybe lastly, base 5, I have a 0, a 1, a 2, a 3, and lastly a 4. So as you can see that base 2 had 2 digits, 0 and 1. Base 3 had 3 digits, 0, 1 and 2. Base 4 had 4 digits, 0, 1, 2 and 3. Base 5 had 5 digits, which is 0, 1, 2, 3 and 4. This is how the notations in various bases are configured. And that's why I gave you the definition that a number base refers to the number of independent digits or notations in a particular number counting system. So based on what I've just written down here, it also describes the definition I gave to you earlier, my dear student and viewers. In mathematics, my dear students and viewers, the most commonly used counting systems are the binary number system, the octal number system, the decimal number system, and the hexadecimal number systems. I'll begin to talk about each of them one by one, starting with the binary number system. So first of all, I said is the binary number system. For the binary number system, you've seen the word bi. The word bi speaks of 2. So when you talk about bi, like for instance, the word bi speaks of 2. For instance, you have words like bimetallic, which means a two metal, like a bimetallic strip, used in physics a lot. So the word bi talks about 2. So speaking of 2, meaning that the word binary number system is referring to the base 2 number system. In the base 2 number system, its notations, I've used it earlier, are 0 and 1. This particular binary system is used largely in coding in computer systems are done. They are done in binary. The second most commonly used number system in mathematics is the octal number system. In the octal number system, you've seen the word octa. The word octa is the word synonymous with 8. For instance, we have shapes like octagon. Octagon is an eight-sided polygon. It's an eight-sided polygon. So for talking about octa, that of course you begin to think about numbers in base 8. So the octal number system refers to the base 8 number system. Its notations, its digits, so are for the base 8 number system. Its digits, just like what we had here, will be for the base 8 number system. Its digits will be a 0, a 1, a 2, a 3, 4, 5, 6, and lastly a 7. The third most commonly used number system in mathematics is the decimal number system. For the decimal number system, you've seen the word deci. The word deci means 1/10 of a whole. For instance, word like decimeter. Decimeter is 1/10 of a meter. So talking about the word deci, it brings to mind a 10. So the decimal number system is the base 10 system of counting, which is the one I told you earlier that it emanated from the Indian culture and then it spread across the rest of the world. It is the most widely used counting system all over in the world. You may not know it, but most people people count in base 10 without even being conscious of what they have been doing. So that is the base 10 counting system. Its notations are, so for the base 10, its notations are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are the digits, and it has 10 digits. Its highest number, or its highest digit or notation, is a 9. So this is the decimal number system, the third most widely used. There is a fourth one, and that is the hexadecimal number system of counting. For the hexadecimal number system, you've seen the word hex. The word hex is synonymous with 6. For instance, objects like the hexagon, it's a 6-sided polygon. All right. Then you've also seen the word decimal. Decimal, I told you, has to do with 10, right? With 10. So you have a hexadecimal. So a 6 plus 10, which is 16. So the hexadecimal system is a base 16 number system. It's also used in computing. This is used for computer. Most of the programs are written in this format, in hexadecimal number system format. This is what it's used. So in terms of its digits, for our base 16, its digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 9. Let's put it here, 9. Then it also has letters also. So there is A, B, C, D, E, and F. The 10 is for a 10. The B is 11. The C is 12. The D is 13. The E is 14. And the F is for 15. That's how it is. I know it's base 16, so it has 16 notations from numbers 0 to 9, and then letters A to F. That's what it has. And I'm showing you what the alphabet stands for in terms of its notations. So these are the 4 most commonly used number systems in mathematics. In closing, let me just add these 2 facts. If you see a number written without a subscript, as in a base attached to it, it's assumed that that number is in base 10. Yes. So for instance, if you see a number like 778 with no subscript attached here, then it's assumed to be in base 10. That is the assumption. It's like in mathematics, seeing a number without a sign, it's assumed to be a plus sign. Another word for base in mathematics is radix. It's not really commonly used, but it's very legit. If you use that term, anybody that has an understanding will know exactly what you're talking about. So the word radix is also another word for base, but it's not really commonly used in teaching, but it is very legit. My dear students and viewers, in our next class, we will be talking about how to convert numbers in base 10 to other bases, and also how to convert numbers in other bases to base 10. My dear students and viewers, in our next video, we will delve deeper. Keep watching the videos of Mathsx, like, subscribe, and share with your friends. As you do so, God bless you.